Last time, in part 15, we followed the claim that a machine can read a mind at a distance, and we watched that claim run into the physics of the skull. This episode goes up. Part 16 of Knowledge Targeting asks what satellites actually do, what they are merely alleged to do, and how a single page in the targeted individual literature manages to hold both at once. Welcome to satellite-based surveillance and targeting systems. That sentence closes a table in a compilation the targeted individual literature calls the Mind Weapon document. It is filed in our knowledge base as Item 19 under the heading Satellite Spies. The shocking truth. Read plainly, it does two things at once. It asserts that an arsenal of orbital weapons exists, and it explains in the same breath how a person exposed to those weapons could be made to look mentally ill. Knowledge Targeting is a 50-part documentary series produced by TI One Voice. Its method is simple and unglamorous. We take the documents that circulate in this community, and we check them one claim at a time against the public record. Some claims survive that. Some do not. Many sit in an honest middle where the evidence is thin and the right answer is that nobody outside a classified program actually knows. This is part 16 of 50, and the second episode in our section on the technology of targeting. Part 15 examined remote neural monitoring, the claim that thought can be read from a distance. Part 17 will turn to the weaponization of 5th and 6th generation mobile networks and massive antenna arrays. Between those two episodes sits the oldest and most powerful image in the whole of this literature: the unblinking eye in orbit. Everything we cite in this series lives on TI One Voice at one.witisk.org. It holds an evidence library where targets file dated, structured accounts of what happened to them. It holds a knowledge base of several thousand documents, including the compilation this episode examines. And it holds a community wall, where people who have been told they are alone can find that they are not alone after all. There is also TITV, our round-the-clock live stream, at meet.witisk.org, under Public, TITV. It runs this series, interviews, and documentary material continuously, so that a person awake at 3 in the morning has something other than silence. Every episode also has a written companion article on the platform, with the citations laid out in full, because a claim you can check is worth more than a claim you can only hear. Here is how this episode was assembled. The chapter text is the spine. Around it, we run a retrieval search across the TI One Voice knowledge base, thousands of documents, indexed by meaning rather than keyword, and pull the passages that bear on each section. Retrieval is loose, so every passage is read before it is used. Where the knowledge base supplies a number or a source, we say so out loud. This episode keeps 3 registers apart, and it will keep naming them. Demonstrated means a named system, a named operator, and a date you can look up. Filed means a patent or a contract exists on paper, which proves a filing, not a working device, and certainly not a deployed one. Claimed means testimony or inference. All 3 deserve a hearing. None of them is allowed to borrow the authority of another. A word to anyone watching who believes they are being targeted from orbit. Nothing in this episode tells you what is or is not happening to you. We are examining a document, not diagnosing a person. If we conclude that a particular technology cannot work at a particular range, that is a statement about the technology. It is not a statement about your credibility. That distinction matters, and we will hold it all the way through. The road ahead has 6 stages. First, the one row a parliament actually investigated, the global interception arrangement known as Echelon. Second, the boldest claim on the page, continuous audio and video of anyone, anywhere, tested against orbital mechanics. Third, the table itself, all 3 columns. Fourth, patent literacy, what a granted patent certifies and what it does not. Fifth, one invention traced to its source. Sixth, how to read a mixed page. So let us put the table on the examining table. 5 rows, 3 columns. One page that has circulated in this community for years, quoted, screenshotted and forwarded, usually without anyone stopping to open the documents it cites. We are going to open them. And the first thing to notice is not what the table says, but how carefully it is arranged to be read as a single, unified body of evidence. The structure is almost bureaucratic, and that is part of its power. Each row names a technology. The middle column states an alleged criminal use. The right column offers a potential good use, as though the compiler were preempting the objection that such a thing should simply be banned. Rows sit in a grid. A grid implies that its entries are of equal standing. On this page, they are emphatically not. Return to that closing sentence because its second claim is the more interesting one. It says these tools can manufacture the appearance of a schizophrenic break. Set aside whether the tools exist. The underlying observation is documented and serious. A person who reports voices, sensations through walls or unseen watchers is, in most clinical and police settings, routed toward psychiatry long before anyone routes them toward an investigation. That hazard is real. Here is what makes this particular page worth an entire episode. Most electronic harassment claims cannot be checked at all. This one can. 3 of its 5 rows cite an actual United States patent number, an inventor of record, and a grant date. That is a rare gift in this literature, a claim with a filing cabinet behind it. We looked all 3 up. What we found is the substance of this episode. So here is the honest arithmetic of the page. 1 row describes a global interception system that a European legislature investigated and confirmed. 4 rows describe technologies whose existence, at the ranges and under the conditions claimed, remains genuinely contested. 1 and 4. That ratio is the whole problem, because a reader who verifies the first row often extends its credibility across the other 4 without checking a single thing. Now the finding that reframes the entire page. Of the 3 rows that cite real patents, not one of those patents mentions a satellite. Not in the claims, not in the abstract, not in the drawings. The table's most frightening word, satellite-based, is the compiler's addition, layered on top of genuine documents that never make that claim themselves. The paperwork is real. The orbit is editorial, and the difference matters enormously. Meanwhile, the real capability is not secret at all. Commercial optical satellites resolve ground detail at around 30 centimeters, enough to count vehicles, not enough to identify a face. Radar imagers such as the European Sentinel-1 see through cloud and darkness at meter scale. Constellations of small satellites now photograph the entire land surface of the Earth every day. All of that is documented, published, and sold. None of it identifies a named individual. 2 distinctions decide this chapter, and we will repeat them. Imaging is not tracking a person. A satellite in low Earth orbit travels near 7.5 kilometers per second and passes overhead for minutes, not hours. And observing is not acting. A camera collects light, it does not deliver force. From geostationary orbit, 36,000 kilometers up, any beam has spread across a landscape long before it reaches a body. Which brings us, finally, to the row that needs the least defending. The table's first entry reads Echelon Satellites and describes satellite and computer monitoring of telecommunications worldwide. Unlike almost everything below it on that page, this is not a fringe claim. It is the name given to a signals intelligence sharing arrangement between 5 countries, operating under a wartime descended agreement, with ground stations you can photograph from a public road. For decades this lived in journalism and leaked testimony. That changed at the turn of the millennium. A temporary committee of the European Parliament spent roughly a year taking evidence from journalists, intelligence veterans, and industry, and concluded in a formal report adopted by the full Parliament in 2001 that a global interception system of this kind did in fact exist. That is our baseline. Next, we trace it back to Bletchley Park. So we begin with the strongest row on that table, and we follow it back to its source. Because Echelon did not begin in orbit. It began in hutments with pencil and paper, with mathematicians working under the pressure of a war that could be lost. Before there were satellites to intercept, there were codes to break. And the institutions built to break them never went away. They simply acquired better antennas. In the summer of 1939, with war against Germany all but certain, Britain's government code and cipher school left London for a Victorian estate in Buckinghamshire. Bletchley Park was shabby, sprawling, and unremarkable from the road. Inside its wooden huts, the country assembled the most concentrated collection of mathematical talent ever gathered in one place. By early 1945, nearly 10,000 people worked there, most of them women, almost none of them seeing the whole picture. What they achieved rested on three things, and none of them is disputed. Polish cryptanalysts had broken into Enigma before the war and handed their work to Britain and France. British mathematicians extended it. Engineers then built Colossus, the first programmable electronic computer, running from early 1944. Historians credit the effort with shortening the war by 2 to 3 years. Demonstrated, documented, declassified. That is the standard everything later in this episode has to meet. Now a caution, and it comes from our own knowledge base. Its entry on Bletchley Park states that no documented direct connection between Bletchley and the targeted individual phenomenon has been established in the surveyed literature. We adopt that position. Bletchley matters here for one reason only. It is where mass interception, machine processing, and permanent institutional secrecy were first welded together into a single organization that never afterwards disbanded. Colossus deserves a moment for what it changed. Before it, breaking a cipher was human work at human speed. After it, interception became an industrial process. Signals in at one end sorted intelligence out at the other, at a rate no room full of analysts could match. 10 Colossus machines were running by the end of the war. Every automated filtering system we discuss later in this episode is a descendant of that single idea. From early 1941, American cryptanalysts began arriving in Britain. First a trickle, then a steady flow. The exchange was not friction-free. The British were reluctant to hand their most sensitive techniques to a country not yet at war. The Americans suspected British motives and felt their own capabilities were being undervalued. But the arithmetic of cooperation was overwhelming. Two nations reading the same enemy traffic with different access and strengths achieved far more together than either alone. The cooperation was formalized in 1943 in the Brusa Agreement between the United States and the United Kingdom. It did 4 things. It established the sharing of signals intelligence product. It divided the world into spheres of collection responsibility. It standardized technical protocols so intercepted material could flow between the partners. And it bound both governments to secrecy about the arrangement itself. That 4th provision outlived the war by more than half a century. Brusa was never a public document. It stayed secret for decades. Yet it worked as the founding charter of the English-speaking Signals Intelligence Alliance. Note carefully what that does and does not license. Our knowledge base entry on Operation Corona observes that its cover story is now cited as proof governments can conceal surveillance programs. They plainly can. But that supports saying we do not know. It never supports saying therefore this particular thing exists. After the war, Brusa was renegotiated and enlarged. The result? Signed in 1946 and refined through secret protocols for a decade afterwards, was the UK-USA Agreement. Canada joined in 1948. Australia and New Zealand followed in 1956. 5 nations pooling the products of global interception. The agreement was not merely classified but unacknowledged, and the text itself was not released to the public until 2010. The division of labor was geographical. Each partner took primary responsibility for traffic moving in and out of assigned regions. The United States, with the largest network of stations, satellites, and naval platforms, took the biggest share. Britain covered Europe, the Middle East, and parts of Africa, working from GCHQ at Cheltenham. Canada took the northern latitudes. Australia covered the Pacific and Southeast Asia. New Zealand covered the South Pacific. Voice, fax, telex, later email, all pooled. The physical form of all this is not mysterious. It is antennas. At RAF Menwith Hill in Yorkshire, dozens of white radomes stand in a field, each one a dish sheltered from weather and from casual view. Menwith Hill appears on Ordnance Survey maps. Its radomes are visible from the road, photographed constantly, and argued about in Parliament. What happens inside is classified. That the station exists and what it faces is not. By the late 1990s, according to the European Parliament's later investigation, the partners were intercepting an estimated 3 billion communications every day. Hold that against human scale. No workforce on Earth reads 3 billion messages. The volume is only tractable because traffic is filtered automatically, by keyword and by selector, in lists the system called dictionaries. The computer monitoring named in that mined weapon table was not science fiction. It was operational routine. Here is the part most often misunderstood. A communications satellite in geostationary orbit sits about 36,000 kilometers above the equator, and its downlink beam spills across an entire continent. Anyone with a large enough dish inside that footprint can hear it. Interception, therefore, never required pointing a satellite at anybody. It required standing underneath a broadcast already being sprayed across millions of square kilometers. That is collection by geometry, not collection by targeting. The same geometry cuts the other way, and this is where a great many claims fail. Run the arithmetic. A 3-meter dish transmitting at 10 gigahertz spreads its beam by roughly 1 part in 100. Over 36,000 kilometers, that is a spot about 360 kilometers across. Diffraction sets a floor. From geostationary orbit, you cannot illuminate a person. You can barely illuminate a country. A sensor collects. It does not deliver force. Low Earth orbit imposes its own limit. A satellite 400 kilometers up moves about 7.5 kilometers every second, circles the planet in 90 minutes, and stands above any given point for minutes, not hours. Submeter imagery resolves a vehicle or a rooftop, never a face. Human tracking is real. The knowledge base cites a 2003 paper on geoslavery. But it works through a device somebody carries. So where did the word echelon actually come from? Not from a leak. Not from any official announcement. It arrived in public through journalism, and the way it arrived is worth telling slowly, because it is a case study in what patient inference can establish from outside a closed system, and in exactly where that inference has to stop and say plainly, here I do not know. That second half is the harder discipline. In August 1988, the investigative journalist Duncan Campbell published an article in the New Statesman describing a system he called Echelon. A network of ground stations, satellites, and processing centers, run by the NSA with its partners, intercepting global telecommunications and filtering them for intelligence value. Campbell had no single leaked document. He had years of patient work, and he had already been prosecuted once in 1978 for reporting on signals intelligence. His method matters more than his label. Satellite orbits are publicly calculable, so he worked out coverage from the orbits themselves. He read station locations and antenna configurations from the ground. He interviewed former Signals personnel. He checked every inference against the open technical literature on satellite interception. Triangulate from what is visible to what must operationally be present, then test it against independent sources. That is the discipline this series is trying to borrow. The stations became the vocabulary of the subject. Menwith Hill in Yorkshire, Morwenstow on the Cornish coast, now GCHQ Bude. Sugar Grove in West Virginia and Yakima in Washington state, both since closed. Bad Aibling in Bavaria. Misawa in northern Japan. Waihopai in New Zealand, described in Nikki Hager's 1996 book Secret Power, and Geraldton in Western Australia. The agencies denied the system. The dishes stayed exactly where they were. 3 registers then, before we hand over, demonstrated a global interception network, later investigated by a parliament. Contested the word echelon itself, which may have named only one component before outsiders stretched it across the whole. Claimed that this network targets named individuals with beams or with voices. Are knowledge base flags that last one as unsupported. Interception is not targeting. Next, the committee that put the first register on the public record. So the allegation existed in print for years. What it lacked was an institution willing to test it under oath. That institution was not American. Congressional oversight of the National Security Agency was, at the time, limited and largely deferential. The response came instead from Europe, from a parliament worried about economic espionage against its own companies, and from a committee with a mandate, a deadline, and the power to call witnesses. In 2000, the European Parliament established a temporary committee on the Echelon interception system. Its mandate had 3 parts: to establish whether a global interception system existed, to assess whether it was compatible with European law, and to recommend measures protecting European citizens and businesses. Notice what that mandate assumes and what it does not. It does not assume Echelon is real. It asks the question and it accepts that the answer might be no. The committee did not work from press cuttings. Across roughly a year it heard investigative journalists, including Duncan Campbell, whose reporting had opened the subject. It heard former intelligence officials from several countries. It heard telecommunications engineers and industry representatives who knew how the traffic actually moved. It heard privacy advocates, legal scholars, and officials from member state governments. Then it reviewed documents, many of them heavily redacted, and weighed only what survived. Redaction matters here, and it cuts both ways. Much of what the committee reviewed arrived with passages blacked out, and the members said so plainly. From what remained, they could establish the broad outlines of the system Duncan Campbell had described years earlier. What they could not do was see inside the black bars and declare what was hidden there. Classification is a reason to say we do not know. It is not evidence. In July 2001, the committee produced its report, designated A5-0264-2001. The central finding was not hedged. The existence of a global system for intercepting communications, the report said, is no longer in doubt. It named the National Security Agency and its partners under the UK-USA agreement as the operators. That remains the most comprehensive public document any legislature has ever produced on global signals intelligence. The report went further than its headline. It described architecture. Satellites intercepted where microwave and satellite-borne traffic could be reached, ground stations sited in several cooperating countries, and automated keyword filtering applied to the flow. And it concluded that the system was capable of intercepting private and commercial communications, and not only military and diplomatic ones. That is a demonstrated finding, made by a legislature, and it deserves to be stated plainly without embellishment. It is worth pausing on why this differs in kind. A journalist alleging a secret global surveillance system offers you his sources and his judgment. A parliamentary committee drawn from 15 member states, working under formal rules of procedure, taking testimony and reviewing documents across a year, then reporting to a chamber that votes, offers you something else. Not certainty. A public record contested by people who wanted it wrong that survived the contest. Now the boundary, because it is the whole discipline of this episode. The committee found a system, named its operators, and found evidence of economic espionage, citing cases in which European firms allegedly lost contracts after their communications were intercepted. It did not find that the system was used to harass individual writers, whistleblowers, or private citizens. Capability is confirmed. That specific application is asserted. Those two sentences are not interchangeable and never will be. The full Parliament adopted the committee's resolution on the 5th of September, 2001. 367 voted in favor. 159 voted against. 39 abstained. 6 days later, larger events buried the story completely. But hold the shape of that number, because a third of the chamber was not persuaded. That is what documented looks like. Contested, recorded, opposed on the floor, and carried anyway. The resolution did not stop at findings. It called on member states to strengthen privacy protections, to develop and promote encryption standards that ordinary citizens and businesses could actually use, and to build a European platform for the protection of fundamental rights. Those are the remedies a legislature reaches for when it believes a capability is real. Not denial and not panic. Law, cryptography, and institutions. Remember that shape when we ask what recognition looks like. Return to the table we have been working through. Its echelon row carries 2 columns. The first says interception of global communications, and the European Parliament report anchors it completely. The second says stealing ideas and harassing targets, and nothing in that report comes close to reaching it. Between those columns, the evidence changes category, from documented capability to a claim about intent and application. Here, honestly, the public evidence runs out. If Echelon has a physical face, it looks like this. Royal Air Force Menwith Hill sits in North Yorkshire, roughly 8 miles west of Harrogate. On open moorland you can see from the public road. Dozens of white spheres are spread across the hillside, each about the size of a small building. They are among the most photographed objects in the intelligence world, and that visibility is going to matter more than anything else about them. The site dates to 1954, when the British Ministry of Defense leased it to the United States Army Security Agency as a signals intelligence station. It has expanded steadily ever since. Although it carries a Royal Air Force name, the knowledge base is blunt about the arrangement. The base is operated by the National Security Agency, not by the RAF. The British government acknowledges a support role and declines to discuss capability. Menwith Hill is not unique, and treating it as one singular secret base misses the point entirely. The same partnership maintains Pine Gap in Central Australia, Sugar Grove in West Virginia, Yakima in Washington State, Leitrim in Canada, and Waihopai in New Zealand. Each is a node. The knowledge base notes that Yakima's identification in the European Parliament report is part of what lends the wider picture its credibility. Geography, not rumor. Here is what the white spheres actually do. Each radome shelters a steerable parabolic dish that tracks a communications satellite across the sky and receives what that satellite is already broadcasting downward. The signal is separated, filtered against keyword and selector lists, and the small surviving fraction reaches an analyst. Nothing anywhere in that chain transmits anything at a person. This is collection. Observing is not acting, and the two must never merge. And these dishes are not aimed at military satellites in any narrow sense. They are aimed at the civilian spacecraft that carry the world's telephone calls, faxes, corporate data, and internet traffic. The Intelsats, the Inmarsats, the Eutelsats, and dozens of regional satellites besides. That is precisely why the European Parliament cared. A system pointed at the commercial backbone is, by construction, a system that touches private communications every single day. Now the physics, because it constrains everything that follows. A geostationary communications satellite sits about 36,000 kilometers above the equator. At that range, even a narrow spot beam spreads across hundreds of kilometers of ground, and a global beam covers roughly a third of the planet. That divergence is exactly why one dish in Yorkshire can hear the satellite at all. It is also why no such satellite can address a single person. Men with Hill is not secret in the cinematic sense at all. Journalists photograph it. Local councils debate it. Protesters have stood at its gates for decades, and the local Member of Parliament has raised its operations in the House of Commons. The BBC and The Guardian have reported on it for years. What is withheld is specific capability, specific targets, and output. The existence of the place has never been in question. Hold that as your baseline for the rest of this episode. A field of satellite dishes is a checkable thing. You can drive to it, photograph it, find it on a map, and confirm from independent sources roughly what it does. Its function follows from its location, its antenna configuration, and the known orbits of the satellites it tracks. None of the remaining rows on that table offers you any of this. Because none of those rows names a facility, a location, or an operator that anyone can go and look at. They name patent numbers, 5 of them, and a patent is a very different kind of object from a hillside full of antennas. It proves that somebody wrote a claim down and that an examiner allowed it. It does not prove a device was ever built, bought, or switched on. Stand back from those radomes for a moment. A hillside of dishes in Yorkshire is the physical end of an argument that has occupied lawyers, political scientists, and surveillance scholars for 30 years. The European Parliament's inquiry did not happen in an academic vacuum. Behind it sits a serious body of research asking a single question. When a state can intercept almost anything, what, in practice, still holds it to account? The central tension in that literature is easy to state. Since the 1990s, the ability to intercept, store, search, and analyze communications has expanded enormously, carried by advances in computing, networking, and data science. The mechanisms meant to restrain that ability, oversight committees, judicial warrants, privacy regulators, and internal compliance offices, have not expanded with it. That is the consensus of most scholars working in the field, and it is not a fringe position. The surveillance studies scholar David Lyon gave that condition a name. He called it a governance gap. Not a scandal, not one rogue program, but a structural asymmetry between what intelligence agencies are able to do and what democratic institutions are able to supervise. Naming it matters because it separates two complaints that people usually blur together. One is that the law is too weak. The other is that the law cannot see far enough to be applied. On paper, the law is not weak. The Foreign Intelligence Surveillance Act, passed in the United States in 1978, created a judicial warrant process. Britain's Regulation of Investigatory Powers Act followed in the year 2000. Both are reasonably comprehensive documents. The gap sits in how they operate. Secret legal interpretations, bulk collection exceptions, and oversight bodies short of technical expertise, investigative staff, or the independence to contradict an agency that assures them everything is fine. The Echelon case illustrates the gap precisely. The committee could establish that a global interception system existed and could name the agencies operating it. It could not establish which specific communications were intercepted, under what authority, with what safeguards, or with what consequence for the people whose messages were captured. Confirming that an architecture exists is not the same as auditing how it is used. That distinction is the whole problem, and it remains unresolved. The legal scholar Christopher Kuhner describes a second mechanism, and calls it jurisdiction shopping. Because the UK-USA partners pool what they collect, an agency bound by strict domestic rules can reach material gathered by a partner working under looser ones. The effect is close to arithmetic. The most permissive partner's rules become the standard for the whole network, since anything collected under them is available to everyone, whatever their own law would have allowed. Set the dates side by side and the shape is clear. The UK-USA agreement was signed in 1946. The American warrant statute arrived in 1978, the British one in the year 2000, the European Parliament's report in 2001, and the Snowden disclosures in 2013. Every one of those additions was real. Not one of them closed the distance between what could be collected and what could be checked. Those 2013 disclosures remain the most detailed public documentation of American and British signals operations ever released, and they confirmed the pooling directly. Partners routinely shared intercepted material in ways that let each of them reach communications it could not lawfully have taken itself. That is not a loophole in the arrangement. It is the arrangement. And the knowledge base entry on Switzerland's ONYX system shows this is not only a superpower practice. So the documented concerns are real, and there are many of them. The Johannesburg Principles, cataloged in our knowledge base, demand independent oversight of what a government may classify, and a right to challenge any secrecy decision. That is mainstream legal argument, published, contested, and cited. Now notice what none of that literature contains. Any mechanism at all by which intercepted traffic is turned upon one named person for the purpose of tormenting them. The knowledge base entry on Ronald Diebert draws the same line. His laboratory has documented real, targeted electronic surveillance of journalists and activists, with forensic evidence behind each case, and it separates those proven cases clearly from the far broader claims of the targeted individual literature. The table's compiler did not invent the concern. What the compiler added is a further step the scholarship does not take, from privacy crisis to weapon aimed at a person. So let us read row 1 exactly as it is written, without paraphrase. The capability column credits Echelon with satellite and computer monitoring of all telecommunications worldwide. The criminal use column lists intercepting conversations and emails, stealing ideas, and harassing targets, naming writers and whistleblowers specifically. Two entirely different kinds of statement are sitting inside a single row of a table, and the row itself offers the reader no way at all of telling them apart. Separate them. The first half, a global interception capability, is the part the European Parliament substantiated and the part surveillance scholarship treats as a structural condition of modern signals intelligence. The second half, that intercepted material is then turned upon named individuals to harass them, is a claim about intent and application which the public record does not support. Here the evidence runs out. Unsupported, though, is not the same word as false. It means unproven. The method is the one this series uses everywhere. Name the system. Name the evidence offered for it. Ask whether that evidence is specific and checkable by somebody else. One document in our knowledge base argues that no claim of satellite surveillance can be dismissed in advance. That is fair enough, and it is also not an argument. A claim that cannot be dismissed has not thereby been supported. Unfalsifiable is not proven. From here the table changes character. Row 1 pointed at a named program, a named alliance, and a parliamentary report anyone can download and read this evening. Row 2 points at nothing you can look up. It is also the boldest claim on the page, and the one most often quoted back at frightened people by others who never checked it. So we are going to read it slowly in its own words. The stated criminal use for that row is gathering material for blackmail and oppressing targets and other citizens. The potential good use, in the table's now familiar boilerplate, is monitoring and stopping terrorists and other criminals. Taken literally, the row asserts continuous, indoor, individually targeted observation of a private person from orbit. That would be a technological achievement far beyond anything any government has publicly acknowledged, or any known satellite system has ever been shown to do. Notice what the row does not do. Unlike Echelon, it names no program, no agency, no satellite system, and no resolution figure. Audiovisual satellites is a category asserted rather than a system identified, a phrase loose enough to stretch from a keyhole reconnaissance satellite to an orbital platform out of a film. Row 1 could be checked against a parliamentary report. In row 2 there is simply nothing there to check. Before testing that specific claim, it is worth being fair to the technology it borrows its credibility from. Reconnaissance satellites are real, and they are genuinely remarkable. The United States National Reconnaissance Office has flown high-resolution imaging satellites for decades, resolving objects on the ground to a fraction of a meter. Commercial operators now sell submeter imagery openly, and one company's fleet photographs the planet's entire landmass every single day at roughly 3-meter detail. The Keyhole lineage runs back to 1960, when a Corona capsule returned the first film ever shot from orbit. Gambit followed in 63, a second Gambit in 66, the enormous Hexagon in 71, and in 1976 the KH-11, which sent its pictures down electronically instead of dropping them. Corona also flew behind a cover story. That proves a government can conceal a program. It does not prove any particular capability exists. How sharp are they today? Nobody outside the program knows because the figures are classified. What does exist is decades of inference by astronomers, satellite trackers, and independent analysts, working from orbital parameters, mirror aperture, and the physics of looking down through air. Their consensus lands at 10 to 15 centimeters. That is enough to identify a vehicle type, perhaps a license plate. It is not enough to read a headline or be certain of a face. Carry two distinctions forward. Imaging is not tracking. A satellite photographs a place for the few minutes it is overhead, not a person continuously. And observing is not acting. A sensor collects, it does not deliver force. Whether continuous coverage of one house is even possible is not a question of opinion or of secrecy. It is orbital mechanics, brief low-orbit passes, and 36,000 kilometers of distance. Those numbers come next. So let us not skip past it. To judge that claim honestly, we have to understand how satellites actually move, because the physics is not negotiable and it is not classified. Everything in orbit is falling. A satellite is dropping constantly toward the center of the Earth, and moving forward fast enough that the surface curves away beneath it at exactly the same rate. That single balance sets everything else that follows. The speed needed to hold that balance depends entirely on altitude. Lower orbits demand higher speed. Low Earth orbit, the band used by every high-resolution imaging satellite, runs from roughly 160 kilometers up to 2,000. The International Space Station sits near 400 kilometers. At that height, a spacecraft travels about 7.7 kilometers every second and circles the whole planet in 93 minutes. Nobody chose those numbers. Climb to 800 kilometers and the satellite slows a little to about 7.5 kilometers per second, taking 101 minutes to come round again. These are not engineering choices. They follow from Kepler's third law, which governs artificial satellites exactly as it governs moons and planets. The square of the orbital period tracks the cube of the orbit size. There is no way around it. Set the periods side by side and the shape of the problem appears. 400 kilometers, 93 minutes. 800 kilometers, 101. 2,000 kilometers, 127. Then the scale breaks, to take a full day to circle the Earth, and so appear to hang still above one spot. A satellite must climb to 35,786 kilometers. Hold that number for a moment. 90 minutes to circle the Earth does not mean 90 minutes between visits. The planet turns underneath. Most imaging satellites fly sun-synchronous polar orbits, which give global coverage under consistent lighting, and a single satellite in such an orbit typically comes back over a mid-latitude city like London once every 3 to 5 days. Not several times daily. Not continuously. Once every few days. That figure is not secret. It falls straight out of the orbit. And when the satellite does arrive, it does not linger. From horizon to horizon, a low orbit pass lasts a few minutes at most, and the useful window, when the target lies near enough to straight below for good geometry, is shorter still. Ground stations track these passes with steerable dishes precisely because the window is so tight. minutes of opportunity, then hours or days of nothing at all. That is the rhythm of orbit. The knowledge base entry on the National Reconnaissance Office puts it plainly. Low-orbit satellites deliver high resolution but limited coverage and limited revisit. So persistent watch requires many satellites spread across different orbital planes. The entry on space-based space surveillance is blunter still. One satellite passes a given region once every 90 minutes. 4 would be needed for anything approaching continuous cover. And orbits are predictable, so the gaps are predictable too. Against that, physics set the claim. In a widely circulated article held in our knowledge base, John Fleming writes that a spy satellite can follow a person's every movement, indoors in any weather, and that there is nowhere on Earth to hide. 3 satellites, he says, blanket the world. Blanket with what? He does not specify a sensor, an aperture, an orbit, or a resolution. This is assertion, not measurement. There are only 2 ways out of the revisit problem, and the first is height. Climb to 36,000 kilometers above the equator and your orbital period stretches to a full 24 hours. You now turn at exactly the rate the Earth turns. So from the ground you appear to hang motionless in one patch of sky. This is geostationary orbit, and it is genuinely continuous. It is also where the trouble starts. Geostationary orbit is where the weather satellites live, along with communications relays and some missile warning platforms. The American GEOES spacecraft have watched the same hemisphere without a break for decades, and their imagery fills every forecast you have ever seen. They resolve hurricanes, fronts, and cloud structure beautifully. What they cannot resolve is an individual building, never mind a person standing beside it. That trade is not an oversight or a limitation of budget. It is optics. Here is why. Diffraction sets a hard floor on what any lens or mirror can separate. By the Rayleigh criterion, at visible wavelengths around 500 nanometers, a telescope 36,000 kilometers from its target needs an aperture near 22 meters just to resolve 1 meter on the ground, a car barely. To reach 10 centimeters, enough to identify a person, it needs about 220 meters. Read that again. The largest telescope mirror ever flown is Hubble's, at 2.4 meters. The gap between 2.4 and 220 is not a matter of refinement or budget. It is a different class of launch vehicle, a different way of making mirrors, and deployment mechanisms nobody has built. Classification cannot close that gap either, because diffraction is a property of light itself, not a secret that could be kept. So the geostationary route fails, and it fails on physics rather than on secrecy. A satellite parked over the equator can indeed stare at one place forever. What it sees at that place is weather. The claim of round-the-clock observation of a named individual is not merely unproven from that orbit. It is incompatible with what an aperture of that size, at that distance, can deliver. Height buys presence and destroys detail. The second escape from the revisit problem is numbers. Put up enough satellites, phased so that as one drops below the horizon another is already rising, and coverage becomes continuous. This is a solved problem for communications. Iridium does it with 66 satellites. Starlink does it with thousands. The knowledge base notes that proliferating constellations are already cutting revisit times from hours down to minutes. That is real, and it is accelerating. But a communications satellite and an imaging satellite are not the same animal. A transponder and a phased array antenna are comparatively light, cheap, and simple to build in volume. A high-resolution imager needs a precisely figured mirror, lenses, detectors, cooling systems, and the power and mass budget to carry all of them into orbit. Multiply that by a whole constellation, and by the launches required, and the numbers stop being merely large. That is the arithmetic. There is also the problem of hiding it. Every large launch is observed, catalogued, and timed. Amateur satellite trackers working with stopwatches and small telescopes have located classified reconnaissance satellites for decades and published their orbital elements openly. A secret fleet large enough to keep one address permanently in view would demand a launch cadence no nation currently possesses, and it would be visible from a suburban back garden with a pair of binoculars. Cost closes the argument. A single reconnaissance satellite of the KH-11 class is estimated to cost several $billion. A constellation large enough to hold continuous coverage of one point on the ground would run to hundreds of billions for one point. Extend that to the thousands of people who report being watched this way, and the bill exceeds the entire American intelligence budget. That is not skepticism. It is multiplication. Now the fair counterpoint. An Air Force study in our knowledge base New World Vistas argues for distributed constellations of small satellites working with airborne and ground sensors, and warns against judging surveillance by resolution alone. That is a serious point. Fusing many weak sensors can reveal patterns no single sharp image would. But note what it is. A research agenda from the 1990s, not a deployed system and not a satellite watching a bedroom. And even a perfect constellation would not solve the last problem, which is not resolution at all. It is line of sight. An optical sensor sees what faces the sky. Roofs, roads, vehicles, pavement. It does not see through a ceiling. Radar can penetrate some materials but cannot render a recognizable individual. Thermal imaging can sense heat through thin walls but cannot resolve a face or read a page. No orbit changes that. None of this means nobody is watching. It means this particular mechanism, a satellite running continuous indoor surveillance of one chosen person, collides with orbital mechanics, with diffraction, with cost, and with line of sight. Where the physics ends, the honest answer is that we do not know everything, and classification is not evidence. So next, look at the companies who image the Earth for a living, and what they can actually deliver. So the physics sets the ceiling. But there is a second constraint, and it is made of money. Before we judge what a satellite could secretly do, it is worth looking hard at what the satellite industry openly does at enormous expense with published specifications and paying customers. The commercial Earth observation business is not hiding its capabilities. It advertises them. And what it advertises tells us where the real edge of this technology actually sits. 3 companies dominate commercial Earth observation. Maxar, formerly Digital Globe, Airbus Defence and Space, and Planet Labs. Between them they fly the imaging constellations that governments, insurers, newsrooms, and universities actually buy from. Their capabilities are a matter of public record. Published in technical specifications, demonstrated in sample imagery any customer can inspect, and constrained by exactly the physics we have just walked through. Nothing about them is classified. That is precisely what makes them such a useful yardstick. Maxar's Worldview Legion constellation is the current state-of-the-art in commercial Earth observation. Its best resolution is 30 centimeters per pixel. At that scale you can identify a vehicle, a shipping container, a road, a rooftop. You cannot identify a human being. 30 centimeters is about the length of a school ruler, and a person seen from directly overhead occupies a couple of pixels of scalp. Resolving objects is not recognizing identities. Set the 2 strategies beside each other and the trade becomes obvious. Legion buys detail and pays for it in weighting. The Doves buy coverage and pay for it in blur. Both are optical, so both are stopped by a cloud, and stopped far more completely by a roof. Neither design is a compromise anyone chose. It is what the aperture, the orbit, and the budget will allow, and everybody in the business knows it. Planet Labs took the opposite bet. Instead of a few exquisite satellites, it flies more than 150 Doves, each roughly the size of a shoebox. Together they photograph the entire landmass of the Earth every single day. That is a genuine achievement in coverage. But their resolution is 3 to 5 meters per pixel. A car is invisible at that scale, a person unthinkable, and most buildings are a smudge of roof. Here is the rule that neither engineering nor money has broken. Frequent revisits come at low resolution. High resolution comes with long waits. A wider swath means coarser pixels. Finer pixels mean a narrower strip and a longer gap between passes. No publicly known system, commercial, military, or intelligence, has escaped that trade. And notice what this rules out: not merely a particular satellite, but the whole shape of the capability being alleged. And even that modest capability is ruinously expensive. 15 looks a day at 30 centimeters takes 6 spacecraft, launch vehicles, ground stations, and a capital investment in the billions of dollars, recovered only from a global base of governments and corporations paying premium prices for timely imagery. Our knowledge base preserves an older figure for comparison. The satellite business earning some $26 billion across 1998. This is an industry, not a hidden workshop. 15 looks a day sounds enormous until you convert it into time. 15 passes spread across 24 hours is a glance roughly every 90 minutes. Each lasting seconds, each from a different angle, each defeated by any cloud that happens to be in the way. Between those glances there is nothing at all. A photograph is not a feed. Continuous watching is not a faster version of imaging. It is a different thing entirely. So the audiovisual satellite row fails on 3 independent grounds, any one of which would be enough on its own. It describes a capability no known system possesses. It contradicts the physics of optical imaging from orbit, because visible light does not travel through a roof. And it would demand an investment larger than any acknowledged space program in history. Beyond the bare assertion, the table offers nothing. Here the evidence simply runs out. Now, none of that makes the underlying fear irrational, and it matters enormously that we say so before leaving this row. The dread that your private life could be watched and recorded, and then used against you, is old and well-founded. It runs straight through the documented history of intelligence agencies. And surveillance by other means, cameras, drones, informants, network monitoring, is real, documented, and entirely worth being angry about. That sentence comes from John Fleming's essay, The Shocking Menace of Satellite Surveillance, held in our knowledge base and quoted across this literature for 20 years. Notice carefully what it does. It asserts with real force and then offers a Roman proverb, time reveals all things, in the place where a citation should be. Conviction is not evidence. We can take the fear seriously and still say the sentence proves nothing whatever. Because the history here is genuinely damning. The KGB compromised foreign diplomats through recorded liaisons. The FBI under J. Edgar Hoover surveilled civil rights leaders and sent one of them an anonymous letter urging him to kill himself. The East German Stasi cultivated an informant network that reached into marriages and kitchens. None of that is conspiracy theory. It is archive-established history, opened up after the regimes that practiced it collapsed. Our knowledge base holds the paper trail. Operation Minaret placed American citizens on watch lists for their politics, without any warrant. Socialist Workers' Party versus Attorney General established a pattern of surveillance where no crime was ever alleged. And in 1971, ordinary citizens burgled a small FBI office in Media, Pennsylvania, and handed the files to the press. Every one of these was proved by documents and sworn testimony, not inferred from official silence. Hold the 2 columns apart and the asymmetry is stark. On one side, named agencies, dated operations, court records, and opened archives. On the other, no system designation, no specification, no sample imagery, no procurement document. And a warning about the easiest mistake in this genre. Some capabilities genuinely are classified, and that fact supports saying we do not know. It never supports saying therefore it exists. Absence of published capability is not evidence of a hidden one. So hold both halves at once, because this is the discipline the whole series runs on. Surveillance really is used as a weapon, and fearing it is not paranoia. But a real fear does not certify a particular machine. The question this row raises was never whether coercive watching exists, because it plainly does. The question is whether a satellite is doing it continuously through your ceiling. On that specific question, the evidence is uniformly negative. Which brings us to the table itself entire. It is worth laying all 5 rows out together, because seeing them side by side is far more useful than meeting them one at a time. In the Mind Weapon compilation, the table carries 3 columns: the technology, its alleged criminal use, and a proposed good use. 5 rows, 1 confident layout, and hiding inside it 3 quite different kinds of claim. Read the technology column aloud and the rows sound alike. Echelon satellites, audiovisual satellites, an interactive transector device, altering consciousness, neurophones, same typeface, same confident tone, same 3 columns. But they are not the same kind of statement at all. 2 rows cite nothing whatever. 3 cite specific granted United States patents, with numbers, inventors, and dates. That difference is invisible in the layout, and it is utterly decisive for the reader. Take the 2 unsupported rows first. Echelon and the audiovisual satellites cite no patent, no contract, no system designation, nothing a reader can pull and examine. They stand or fall entirely on documentary evidence, such as the European Parliament's inquiry into Echelon, which we weighed earlier in this episode. That inquiry found an interception system for commercial and civil traffic. It did not find a satellite watching one named person inside their own home. The other 3 rows do something this genre of literature very rarely offers. Each cites a specific, granted United States patent, complete with number, inventor, and date. The transector row cites a patent granted in January 1990. The consciousness row cites 2, granted in 1992 and 1994. The neurophone row cites 2 more, the earlier granted all the way back in 1968. An inventor named on a patent is not an accused person. That is a genuinely checkable claim, and checkable claims are rare enough in this field to be treasured. So we checked it. We pulled the actual filings from the patent record, the drawings, the specification, and the formal legal claims, rather than trusting the table's one-line summary of them. What we found both vindicates the table and complicates it, in ways a fair-minded reader needs to see clearly. That is where we go next. So we pulled the filings. Before we open them, understand why this matters more than it might first seem. Almost everything in the wider electronic harassment literature is, by its nature, unfalsifiable, a reported sensation, an unnamed device, nothing a third party can examine. A cited, granted patent is the exact opposite of that. It is a public document, and it is waiting for you. That difference deserves a moment, because everything that follows depends on it. A granted United States patent is published by the government at the moment of grant. It carries the inventor's name, the filing and the grant dates, the drawings, and a formal set of legal claims defining exactly what is being protected. It stays public, searchable, and free of charge, indefinitely. Nobody here is asking you to trust an anonymous assertion. You are being pointed at a specific document and told to go and read it. So we did. Keep 3 registers apart because this whole section depends on it. Demonstrated means a named system, a named operator, a year. Orbital reconnaissance is real and largely public. Filed means a patent, a contract, a procurement record. It proves a filing and nothing beyond that. Claimed means testimony and inference, labeled as such every time. The table we are examining slides between all 3 without ever telling the reader which one it is using. The knowledge base entry on the United States Patent and Trademark Office describes archives holding millions of records across 2 centuries. Indexed since 2013 by a classification scheme running to roughly 250,000 entries. That index exists so anything filed can be found again by anybody. Compare that with a private incident log, which the same knowledge base notes carries no recognized evidentiary value. One is a public record. The other is not. So what does an examiner actually do? 3 things. Is the invention new, measured against everything already on record? Is it non-obvious to somebody skilled in that field? And is it described clearly enough that such a person could, in principle, build it? That is the entire test. It is a test of the paperwork, conducted against a very large library of other paperwork. It is not, at any point, a test of the world. Now the other half, which almost nobody says out loud. An examiner does not build a prototype. An examiner does not verify that the device works as described, still less that it works as well as the inventor claims. An examiner does not investigate whether anyone ever manufactured it, deployed it, or used it, and for what purpose. A grant certifies that an idea was judged original and clearly written. Nothing whatsoever beyond that. The reason is structural, not sloppy. The patent bargain is disclosure in exchange for a temporary monopoly. The inventor explains the invention publicly. The public gets a permanent, searchable record of what was claimed. Validation was never part of the deal. So the fact that a patent exists for something does not mean that something exists as a working, deployed system. It means a person filed, an examiner judged the idea novel, and a government published the result. One real number, taken straight from the table itself. 5 distinct United States patents are cited across its 3 most technical rows, filed and granted over a span of 26 years, from a neurophone patent granted in 1968 to a second consciousness patent granted in 1994. We pulled every one of them. The numbers are right. The inventors are right. The grant dates are right. That deserves saying plainly. Say it plainly, then, because fairness cuts both ways. This table is not fabricating citations. 3 different people really did file these applications decades apart in different technical fields with no connection between them that any record shows. Whatever you conclude about the accusation built on top of them, the underlying documents are genuine. That is unusual in this literature, and it is precisely why these 3 rows are worth the work of checking properly. Here they are. 2 from Patrick Flanagan. A nervous system excitation device granted in 1968, and a companion method granted in 1972. 1 from Larry Rowan, the interactive transector, granted in 1990. 2 from James Gall, both titled Method and System for Altering Consciousness, granted in 1992 and 1994. 5 documents, 3 inventors, all of them public, and every one of them still readable today. The obvious objection: surely the genuinely dangerous ones are classified. Sometimes they are. The Invention Secrecy Act of 1951 lets the government impose secrecy orders on applications judged a threat to national security, and the knowledge base records roughly 5,000 to 6,000 such orders active in recent decades. But notice carefully what that supports. Supports we do not know. It does not support, therefore it exists. That inference is this genre's characteristic failure. Laid out in order, the dates tell you something the table does not. 1968 and 1972. A hearing device for the deaf. 1990. A weapons targeting system. 1992 and 1994. An acoustic method for altering states of mind. 3 separate technical traditions, 3 separate purposes, 26 years apart. The only thing binding them together is the table itself, and the column headings somebody wrote above them. And here is the hinge this whole chapter turns on. Read the filed text of all 5 patents, not the table's paraphrase of them, the actual documents, and not one mentions a satellite. Not once. The word satellite, which the table attaches to the transector and to the neurophone specifically, appears in the table's own labels for those rows. It does not appear anywhere in the patents those rows cite. That absence means something because patents about satellites say so on their face. The knowledge base points to United States Patent 5345238, titled Satellite Signature Suppression Shield, granted in 1994 and later cited by the intelligence historian Jeffrey Richelson in his work on stealth reconnaissance. The word sits right there in the title, in plain sight. When an inventor is patenting something built to go to orbit, the document does not hide it. Now to the row carrying the strongest claim. United States Patent 4893815 is real. Larry Rowan filed it in August 1987. It was granted in January 1990. Read on its own terms, it is genuinely a weapons patent. The abstract describes identifying and tracking targets, integrating sensors with projectile launching mechanisms. The drawings show target acquisition hardware, ballistic computation, automated engagement. This is not an innocuous invention, and we will not pretend otherwise. So the fair reading is not that the table picked a harmless document. It picked a real weapons targeting patent, of a kind that appeared in hundreds of filings during the same period. What it then did was add three things the patent does not contain: the word SAT-based, the phrase political targets, and the description to terrorize or torture them. Set the two columns beside each other, and the addition becomes visible. In the Patent Office's own language, the title reads, Interactive Transector Device, Commercial and Military Grade. That is the whole of what the office certified. The filed text does not mention a satellite. It does not describe locking onto a human political target. It does not use the language of terror or of torture. It does not claim orbital delivery, intercontinental range, stealth, or covertness. This is the vocabulary of conventional weapons targeting. So the leap from a 1987 weapons targeting filing to a satellite-borne weapon aimed at a chosen dissident is the compiler's addition. Nothing in the document survives that journey, and nothing in it was ever meant to. A low Earth orbit pass lasts minutes, not hours. Geostationary orbit sits some 36,000 kilometers away. Rowan's specification addresses none of that, and it was never asked to because the filing was never about orbit at all. The mechanism is worth naming because you will see it again. Start with a real, checkable document. Keep the number and the inventor's name intact, which is exactly what makes the row feel verified. Then attach, in your own label rather than in theirs, the capability that would make it frightening: orbital, remote, aimed at one chosen person. The citation stays honest. The claim built on top of it does not. One row down and the pattern is already visible. Larry Rowan is not accused of anything here. His filing says precisely what it says, and the additions are somebody else's. The only question is what the table put on top afterwards. Row 4 does the same thing to two more genuine patents, the consciousness filings of James Gall, granted in 1992 and 1994. What Gall actually described is stranger than you would guess. That was row 3. Row 4 moves the table's argument from weapons targeting to something stranger, the alteration of consciousness itself. It cites two United States patents granted to James Gall, the first in June 1992, the second in February 1994. Both carry the same title, Method and System for Altering Consciousness. Both are real. And once again, what they actually describe is quieter, and rather more interesting, than the row that cites them. Look at the filing record. The first application went in during January 1991, and was granted on the 23rd of June, 1992, as Patent 5.123.899. The second was filed a year later and granted on the 22nd of February, 1994, as 5.289 for 3.8. Same inventor, same title, one refining the other. Checkable documents, free to read, still public today. So what does Gall's method actually do? It applies several stimuli at once, and his own filings describe sound at carefully calculated, mathematically related frequencies. The theory is entrainment, that the brain tends to drift toward the rhythm it is exposed to, sliding toward the alpha or theta patterns associated with relaxation or altered states. That is a real, testable proposition about applied acoustics. It is also the family of ideas behind commercial brainwave audio. The neurophysiology underneath is genuine and uncontroversial. The brain does produce rhythmic electrical activity in characteristic bands. Delta below 4 Hz, theta from 4 to 8, alpha from 8 to 12, beta from 12 to 30, and gamma above that. Those bands do correlate broadly with sleep, drowsiness, relaxed wakefulness, and alert attention. None of that is fringe. It is in every introductory textbook on electroencephalography, and it has been measured for nearly a century. Where the ground gets softer is the next step. Whether external sound can reliably pull those rhythms toward a chosen state, genuine entrainment rather than just a pleasant hum, is contested and thinly supported in the peer-reviewed literature. Binaural beat recordings have been sold as relaxation aids for decades. The effect sizes reported are modest and inconsistent. So, a testable hypothesis partly tested, unsettled. That is a fair description, and it is not a conspiracy. Keep the 3 registers apart because RAW4 blurs them. Demonstrated brainwave audio exists, is sold openly, and works modestly at best. Filed, 2 granted patents describing a signal generator, transducers on or near the body, and a subject who has agreed to sit down and receive the stimulus. Claimed, satellite-based EEG cloning, aimed at people who never consented. Only the first 2 rest on documents that anyone can go and check. Now follow one thread all the way down to its root, because it is the most human story on this table, and the clearest illustration of the gap between what a patent says and what a compiler builds on top of it. G. Patrick Flanagan was born in 1944 in Oklahoma and raised, by most accounts, in Texas. By any reasonable measure he was a prodigy, and everything that follows is checkable. By his early teens he was building radio receivers and transmitters from scavenged parts. He claimed to have built his first working neurophone prototype at the age of 14, while still in high school. In 1962, aged 17, Life magazine profiled him as one of the country's most promising young scientific minds. He filed his first patent application in July 1967, at 23. The grant followed the summer after that. The device itself was simple, and that simplicity matters enormously. A microphone turned sound into an electrical signal. That signal modulated a radio frequency carrier wave, in the original prototype around 40 kHz. The modulated signal was then applied, through electrodes, to the skin of the listener. 40 kHz sits above human hearing, but it is not a broadcast frequency in any useful sense here. It is a carrier, and it is delivered by wire. The claim attached to that chain was bold. Flanagan argued the electrical signal, passed through skin and the bone of the skull, could stimulate the auditory nerve directly, bypassing the eardrum so a person with damaged eardrums might perceive sound. In essence, a hearing aid that worked by direct electrical stimulation rather than acoustic amplification. Note where every arrow in that chain sits, inside a wired device, touching the head of a listener. The life profile matters because it is independently documented. In 1962, the magazine described a teenager who had built a device that could, in his telling, send sound to the brain through the skin, bypassing the ear entirely. The profile took the claim seriously. For a period in the early 1960s, Flanagan's status as a boy genius was mainstream media attention, not fringe speculation. That is a fact about publicity, though not about physics. Here is the patent's own language, taken from the claims section of the 1968 grant. Electrode means, adapted to be placed on the head of a person, for applying the modulated signal to the skin of that person. Read it slowly. Electrodes, placed on the head, applied to the skin. That is a description of physical contact, written into the legally binding part of the document, by the inventor himself. The full claim runs longer and every clause points the same way. A means for producing an electrical signal varying at an audio frequency. A means for producing a higher frequency carrier. A means for modulating one with the other, and electrodes for the head. Generator and electrodes are parts of a single worn instrument. It is a hearing aid in function and in intent for a person whose ear is pressed against it. Now the negative finding, which is just as checkable as the positive one. Search both Flanagan patents for the words that would matter. Satellite, absent. Laser, absent. Microwave beam, absent. Orbit, uplink. Remote delivery, over-the-air transmission, covert, unwilling, absent, every one. Not buried in a footnote, not tucked into a limiting clause, simply not there in either the 1968 document or the 1972 refinement, and you can check that yourself in an afternoon. The 1972 patent refines the modulation scheme and the electrode arrangement, but the architecture does not change. A contact device, electrodes on the head, signal delivered by conduction rather than through the air. Flanagan pursued the neurophone sincerely as a hearing aid for deaf people. He demonstrated it publicly, at lectures and at trade shows, discussed its limitations, and kept refining it for decades. A medical device in its inventor's own framing. Set the two texts side by side. The table describes a satellite-based weapon that makes a target hear voices. In its words, the laser, microwave or radio wave direction of sound converted to electrical impulse, straight to the target's brain. The patent describes electrodes wired to a generator, worn by a willing user. Same inventor's name, same patent numbers, two completely different machines. Only one of them was ever filed with a patent office. And note what the table never has to say out loud. The patent claims no range at all, because the signal travels by contact. The operating distance is 0 millimeters. To turn that into a satellite weapon, you do not extend the invention, you replace its only working mechanism. The graft is the compiler's work, not Flanagan. A real hearing invention, name and numbers left intact, with a frightening capability bolted on. Stretch that 0 millimeter mechanism to orbit and the physics stops you. A satellite in low Earth orbit, 500 kilometers up, crosses the sky in minutes, not continuously. Geostationary orbit sits about 36,000 kilometers out, and any beam spreads across that distance until precision at the scale of a human head is simply gone. A sensor collects. It does not deliver force. Observing is not acting, and imaging is not tracking a person. One source in our knowledge base puts the point bluntly, and we quote it as one view among several. No satellite, it says, carries an onboard EEG, a neurophone, or any brain mapping device. Be careful with that, though. Some capabilities genuinely are classified, and a blank space in the public record supports we do not know, never therefore it exists. What we can check are the patents, and they say nothing about orbit. So 3 rows now follow the same pattern. A real patent, a real inventor, a real contact-based device, and the words satellite, remote, and unwilling added afterwards by somebody else. But there is one genuine piece of published science underneath all of this, and it deserves naming clearly rather than dismissing. In 1962, the same year Life profiled Flanagan, a researcher published a peer-reviewed paper that changed the conversation entirely. Before we leave that graft, name the honest fact sitting underneath it. There is real published science here, and it deserves daylight rather than the shadow of the exaggerated claim built on top. 1962, the same year Life magazine profiled the teenage Flanagan. A researcher named Alan H. Fry published a paper in the peer-reviewed Journal of Applied Physiology. Not a rumor, not a leaked file, an ordinary scientific paper anyone can still read. The paper was titled Human Auditory System Response to Modulated Electromagnetic Energy. This finding was narrow and strange. Under laboratory conditions, Pulsed microwave energy at particular frequencies made a person perceive a click, a buzz, or a hiss seemingly generated inside the head. Fry was no fringe figure. He was a credentialed researcher publishing in a mainstream physiology journal, describing what he measured, with the caution that such journals demand. The knowledge base entry on the Fry microwave hearing experiments puts the community's stake plainly. It calls the effect central to the scientific foundation of these claims, because it supplies a mechanism where otherwise there would be none. That is a fair description of why the paper matters here. A documented laboratory effect is the load-bearing beam under an entire literature of voice-to-skull assertion, and it will bear only so much weight. The mechanism is now well understood. A pulse of microwave energy is absorbed in tissue near the inner ear, warming it by a tiny fraction of a degree. That warming makes the tissue expand, and the expansion launches a pressure wave the cochlea registers as sound. It bypasses the eardrum entirely, which is why some subjects who are deaf through ordinary hearing pathways still perceive the clicks. That detail alone made the effect famous. Now set the published finding beside the claim built on it. 64 years of replication establish that pulsed microwaves can make a laboratory subject hear a click. The table asserts something else entirely: intelligible speech delivered from orbit, through walls into one chosen skull, without that person's knowledge. Between them lie several unbridged steps: power, range, precision, intelligibility, targeting. Naming that gap is not dismissal of anyone's experience. It is bookkeeping. For things the published record does not contain. First, intelligibility, clicks and buzzes are not sentences. Second, range, laboratory work happens across a room, not across the atmosphere. Third, selectivity, no demonstrated method aims such a pulse at one person in a crowd. Fourth, independent verification outside classified or unverifiable settings. Fry established that the mechanism is physically possible in principle. Possible in principle is not deployed, and certainly not deployed from orbit. Hold both facts at once because the discipline of this series depends on it. A real, documented, peer-reviewed laboratory effect, and an unproven leap from that effect to a deployed orbital weapon aimed at citizens. Neither cancels the other. The knowledge base article on weaponization of the microwave auditory effect says as much, calling it the most scientifically grounded basis for voice-to-skull claims. Grounded basis, note, not proof of deployment. So to the verdict. A single page does not deserve a single grade. The Satellite Spies table holds at least 3 different kinds of claim. One documented fact, several unproven assertions, and several real documents wearing a label their own authors never wrote. Each must be weighed against its own evidence, not against the credibility or incredibility of the row sitting next to it. Take them in order one at a time. Row 1, Echelon, sits closest to solid ground. A real intelligence sharing arrangement, descended from the wartime code-breaking partnership at Bletchley Park and formalized in the UK-USA agreement. A European Parliament committee investigated it and concluded the system existed and could intercept private and commercial communications. Ground stations like RAF Menwith Hill in Yorkshire are real, visible, and photographed from the public road. This row is not speculation. Its existence is documented. But read the row's own accusation carefully. The table's criminal use column says these satellites are used to steal ideas and harass targets, writers, whistleblowers. That is a different proposition from interception at scale, and no European Parliament finding supports it. The knowledge base traces the lineage back to Rhyolite, the 1970s signal satellites it calls the dawn of space-based mass interception. Lineage is real. Individual harassment, on this record, remains asserted. Row 2 names audiovisual satellites allowing round-the-clock surveillance of anyone, even indoors. This one runs straight into orbital mechanics. A satellite in low Earth orbit passes over a given point for a few minutes. Then it is gone, revisiting hours or days later. A geostationary satellite does sit still above you from 36,000 kilometers, where the same aperture that resolves a car becomes a smear tens of meters across. And imaging is not tracking a person. The sharpest commercial imagery resolves about 30 centimeters, enough to count vehicles, not to recognize a face, and nothing in that optical path sees through a roof. The knowledge base notes fairly that proliferating constellations are cutting revisit times from hours towards minutes, a real and serious privacy shift. Minutes is still not continuous, and a rooftop is still not a living room. Observing is not acting. A sensor collects. It does not deliver force. Run the geometry. At 36,000 kilometers, a beam 1/1000th of a degree wide, far tighter than any microwave aperture ever flown, has spread to roughly 600 meters by the time it arrives. Add atmospheric absorption and the power budget, and energy aimed at one skull from orbit becomes a question of arithmetic, not opinion. The numbers are checkable. Here is where the genre's characteristic error appears. That line comes from an opinion column quoting a 1991 book held in the knowledge base, an unverified secondary quotation, and we label it as such. Its logic is the problem. It treats secrecy itself as evidence. Some capabilities genuinely are classified. That fact supports saying we do not know. It never supports saying therefore it exists. Absence of a published capability is not evidence of a hidden one. Rows 3 through 5 are the most nuanced finding of the whole investigation. 3 real, granted, checkable United States patents, 5 documents in total, filed by 3 genuine inventors across 26 years. Larry Rowan's interactive transector describes a real weapons targeting system. James Gall's consciousness patents describe a real acoustic entrainment method. Patrick Flanagan neurophone patents describe a real contact-based hearing device. The table's patent numbers and inventor names are accurate. That part is not fabricated. What none of the 5 patents does in its own file text is mention a satellite. Not one. Search all 5 and the count is 0. The word satellite, the table's most frightening descriptor, the word that converts contact electrodes and proximity weapons into orbital platforms, appears in the table's labeling, and in not a single sentence the inventors themselves wrote. The compiler added the sky. That addition is the finding of this chapter. Be precise about what that finding is not. It is not a claim that no directed energy technology exists anywhere. It is not a claim that no government ever researched these effects. And it is emphatically not a claim that people reporting these experiences are imagining them. It is the narrower, more useful conclusion that these 5 specific citations do not establish the specific weapon this table describes. Narrower claims survive scrutiny. That is the point. Now close the loop on the 3rd column because it belongs to this verdict too. The table's potential good use column repeats one identical phrase across 4 of its 5 rows. The same 8 words justify a documented global interception network, an unproven continuous surveillance claim, and a contact-based hearing aid a deaf man might wear. One sentence for utterly different technologies. Genuine ethical reasoning weighs different tools differently. This does not. The repetition is itself a finding. Weigh what that repetition tells us. A table built from genuine case-by-case ethical reasoning would treat these differently. Interception might legitimately serve counterterrorism. A contact hearing aid might legitimately serve medicine, helping a deaf person hear, which is exactly what its inventor said it was for. A weapon that beams voices into an unwilling skull raises questions of proportionality and coercion that this boilerplate never engages. Different technologies, one sentence, no thought. So read the page as what it is. An advocacy artifact, assembled to make a case, not a neutral technical survey. That does not make any single row false. A document can be badly reasoned and still contain an accurate line. It means the framing deserves less evidentiary weight than the checkable citations underneath it. Which raises the practical question we take up next. What changes once you read this way? So what changes in practice once you read a table like this the way we just have? For a target trying to make sense of their own fear, it offers a vocabulary. That vocabulary separates what is documented from what is merely asserted. And that separation is protective, not diminishing. It does not shrink your experience. It decides which parts of your account can survive contact with someone who does not already believe you. Lean on the unproven claim, a satellite-beamed voice weapon, as though it were established fact, and you hand a skeptic the easiest possible dismissal. Prove the satellite exists. That is a demand no target can meet, because no public record supports it. The conversation ends there, and everything else you had to say goes down with it. One unsupported sentence can sink an otherwise careful account, however much of that account is true. So keep 3 registers apart, and never let them merge. Demonstrated: a named system, a named operator, a launch year, a published resolution. Filed: a patent or a contract exists which proves a filing, not a working device, and certainly not a deployed one. Claimed: testimony that a satellite tracks one named person continuously. All 3 can appear in the same table. Only the first one is evidence of capability. Lean instead on what is actually confirmed, and the case gets harder to wave away. A documented global interception network, checked by a parliament. A well-studied history of institutional harassment of citizens. The documented microwave auditory effect, published in 1962. Each of those can be cited independently by anyone without asking your listener to take your word for anything. That is what a case that survives scrutiny looks like. For a researcher or an advocate, the method is simple and repeatable. When a document cites a specific patent number, pull the patent and read it in full, rather than trusting the compiler's paraphrase. That single habit would have caught every gap in this chapter. The word satellite added to patents that never use it. The remote targeting claim added to a contact-based hearing aid. The mood-altering claim added to an acoustic entrainment method. Treat each row of a table as its own claim with its own evidence. Resist the pull to grade a whole document pass or fail as a single unit, because compilers mix strong rows and weak rows in the same list, and a reader who grades in bulk will either swallow the weak ones or throw the strong ones away. Then ask the plain question that costs nothing to ask. We close this stretch of the chapter where a fair investigation should always begin, with what is actually up there. Not with what a table alleges and not with what a compiler's label implies, but with hardware that has a name, an operator, a launch date, and a published specification. The sky above you is genuinely crowded with instruments. Most of them are not secret at all and never were. Governments operate real reconnaissance satellites. The knowledge base traces the line plainly. From film return capsules in the late 1950s to real-time digital imaging, synthetic aperture radar, and signals intelligence payloads that work through cloud and darkness. Today, a commercial spacecraft like WorldView 3, launched in 2014, resolves about 31 centimeters. Planet Labs flies roughly 200 small satellites imaging the whole landmass daily. All of that is published and none of it is in dispute. Hold that number still because it does more work than people expect. 31 centimeters is the finest commercial optical resolution routinely licensed, and it is genuinely impressive. It also means a car occupies about 10 pixels by 5. Person, seen from directly above, is roughly 1 pixel. There is no face in that image and no name. Imaging is not tracking a person. Those are 2 different claims entirely separated by orders of magnitude. Orbital mechanics constrain everything here. A low Earth orbit satellite sits 500 to 800 kilometers up and travels about 7.5 kilometers every second. It rises, crosses your sky, and sets, all inside about 10 minutes. Geostationary orbit is fixed above one longitude, but it is 35,786 kilometers away. Neither of those gives you continuous, close observation of one walking human being. A sensor collects. It does not transmit force. Observing is not acting, and the arithmetic is unforgiving. A 10-meter dish broadcasting at 10 gigahertz from geostationary orbit produces a beam that has spread to well over 100 kilometers wide by the time it reaches the ground. Spread a megawatt across that footprint and you get tens of microwatts per square meter. Public exposure limits sit near 10 watts per square meter. Signals intelligence from orbit is real and old. The Rhyolite satellites of the early 1970s sat in geostationary orbit and listened to radio traffic across whole continents. The knowledge base calls that series the dawn of space-based mass interception of communications. Note what it intercepted, though: transmitted signals. Radio, telemetry, microwave relay. It did not watch bodies, and it did not know whose hand was on the transmitter key. The receiving end is on the ground, and much of it you can see. The NSA, GCHQ, and their partner agencies operate stations at Menwith Hill in North Yorkshire, at Pine Gap near Alice Springs, and formerly at Sugar Grove in West Virginia. Their physical footprint is visible from public roads. Their function is inferable from antenna configuration and satellite tracking geometry. Secrecy of purpose is not the same as invisibility of hardware. And a parliament checked one of these systems. The European Parliament ran a temporary committee on the Echelon interception system and adopted its report in September 2001. This finding was blunt, and the full text stands in the public record to this day. That is what a confirmed row on a table looks like, investigated by an elected body, published, sourced, and available to anyone who wants to read it. The scholarly literature adds the part that should worry everyone equally. It documents a structural gap between what intelligence agencies can technically do and what democratic institutions can effectively oversee. Surveillance studies scholars David Lyon, Shoshana Zuboff, the Surveillance Studies Network, have spent decades mapping that asymmetry. You do not need a single orbital weapon to exist for that gap to be real and dangerous and worth naming out loud. One argument recurs, and it deserves a straight answer. Some capabilities genuinely are classified. The knowledge base carries a version of it from the Mind Justice UC Davis report, reasoning that because classified research is real, hidden surveillance technology becomes more likely. But classification supports the sentence "we do not know." It does not support the sentence "therefore it exists." Absence of published capability is not evidence of a hidden one. Which brings us to the failure this chapter keeps meeting. A real physical effect gets published. A real patent gets filed. A compiler assembles them into a table and attaches a label the documents themselves never carry. By the fourth step, the row reads like a deployed weapon, and nothing new has been discovered at any point. The chain breaks at step 3 every time, and step 3 leaves fingerprints. Watch how quickly a guess hardens into a figure. A knowledge base entry reasons that if 200 surveillance satellites exist, and if each can monitor 20 human targets, then as many as 4,000 Americans may be under satellite surveillance. Neither premise is sourced. The word "if" carries the whole sentence, and by the end of it the "if" has quietly vanished and only the round total remains, looking like a finding. This chapter does not stand alone. Part 11 takes the microwave auditory effect and the research that followed Frey's 1962 paper much deeper. Part 12 covers directed energy weapons as a category. Part 17 next picks up exactly where we leave off, testing whether ground-based antenna arrays are the terrestrial version of everything we have just examined. Part 25 supplies the institutional history behind the patents and the 1974 Senate study that documented it. The connections run outside the Series 2 surveillance studies, space law under the Outer Space Treaty of 1967, and the scholarship on how real science gets assembled into public claims. Throughout, one discipline holds: define terms precisely, cite carefully, separate observation from inference, and admit uncertainty. The fear underneath this table is old, and in documented cases justified. What remains is what a target can actually do with it. We have walked that table row by row, and now the walking stops. 3 things are worth carrying out of it, and they matter far beyond one photocopied page. The first concerns the single row a parliament actually investigated. The second concerns 3 real inventors whose granted patents were quietly relabeled. The third is a habit of mind, and it is the most useful thing this chapter has to offer anyone. Carry forward 1. 1 row, 1 parliament. Of everything on the satellite spies table, Echelon alone was investigated by an elected parliament and confirmed to exist. Every other row rests on a compiler's paraphrase or a patent's ambiguous wording. That asymmetry is the most important structural fact about the whole page. 1 claim was tested under formal rules of procedure, with sworn testimony and documents. The rest were simply typed out and passed along, uninspected, for decades. The European Parliament set up a temporary committee and worked for roughly a year. It heard sworn testimony, gathered documents, and published its report on the 5th of September, 2001, catalogued as A50264. Its conclusion was blunt. A global interception system of this kind did exist. That is a legislative finding on the record, in a language anyone can look up. Nothing else on the table has anything remotely comparable behind it. Hold the 2 columns apart because the row itself does not. What the committee confirmed was a system for intercepting communications in bulk, run cooperatively by partner states. What the table claims is something else entirely. That this machinery is trained continuously on one named private individual in one house. The first is documented. The second is asserted. They appear in the same row in the same typeface, and they do not carry the same weight. This is the distinction that has to be maintained every single time. Interception on a national scale is documented. Interception aimed at a particular person's kitchen, hour after hour, year after year, is not. The second does not follow from the first, and the report never claimed it did. A system built to sift oceans of traffic is not, by that fact, a system that follows one woman to the supermarket. Here the evidence runs out. The parliamentary finding did not come from nowhere. The journalist Duncan Campbell described the network in the New Statesman in August 1988, 13 years before the committee reported. The knowledge base traces the technical lineage back further, to Rhyolite, an early satellite series built for space-based interception of communications. That lineage is real. The knowledge base also records that researchers extend it, by argument rather than by document, to the monitoring alleged against individuals. Carry forward 2, real patents, borrowed satellite. 3 of the table's 5 rows cite genuine, granted United States patents, filed by 3 real inventors across 26 years. 1968, 1972, 1990, 1992, 1994. Every number in the table checks out against the Patent Office record. The citations are not fabricated, and that is worth saying plainly, because in this field fabricated citations are common enough to be the default suspicion. But a granted patent belongs to the second register, and only the second. It proves that an application was filed, examined, and allowed. It does not prove a working device, a manufactured product, a customer, or a deployment. The Patent Office does not test whether the invention works as described. It tests novelty, not performance. So the correct reading of a patent citation is, somebody wrote this down and paid a fee. Nothing more. Read the specifications carefully and the pattern is immediate. Flanagan 2 patents describe a contact-based hearing aid, sound coupled through the skin. Rowan's describes a weapons targeting system that nowhere mentions orbit. Gall's 2 describe an acoustic entrainment method of the kind sold commercially, then and now as a relaxation aid. 3 inventors, 5 documents, 26 years, and not one sentence anywhere in them about a satellite aimed at an unwilling person. So where did the satellite come from? Came from the table. The word, and the description of a remote weapon aimed at an unwilling victim, are the compiler's additions. They sit in the column-headed description beside a patent number that is entirely genuine, and they borrow its credibility. That is the whole mechanism. Nothing is forged. A true citation is placed next to an untrue caption, and the reader's eye does the rest. Picture the distance a claim has to travel. An application is filed. An examiner grants it. Those 2 steps are what the document certifies. Beyond them lie a working prototype, a manufactured product, and a deployed system in somebody's hands, and the patent says nothing about any of the 3. Most granted patents never reach step 3. Treating a filing as a deployment collapses that entire distance into a footnote, and the collapse is invisible on the page. Now the physics, because it is not optional. Geostationary orbit sits about 36,000 kilometers above the equator. A beam spreads with distance, and the spread depends on wavelength divided by aperture. At 10 gigahertz, a 1-meter antenna up there illuminates a patch of ground roughly 1,000 kilometers across. That is not a beam aimed at a bedroom. It is a beam aimed at a subcontinent, and no amount of secrecy narrows it. Low Earth orbit avoids that problem and creates another. A satellite 300 or 400 kilometers up moves at about 7.5 kilometers a second. It clears the horizon, crosses the sky, and is gone in a handful of minutes. It is overhead. Then it is over Kazakhstan. Commercial constellations have cut revisit times from hours towards minutes, as the knowledge base notes, but a gap of minutes is still a gap. 2 sentences to keep. Imaging is not tracking a person. Submeter imagery resolves a car, a roof, a shipping container, not a face and not a name. And observing is not acting. A sensor gathers energy that is already arriving. It does not send force the other way. Every claim on that table quietly slides from the first thing to the second, and the slide is never argued. It is simply performed. The power budget tells the same story. A communications satellite generates a few kilowatts, and most of that runs the spacecraft. To put a meaningful amount of energy on a square meter of ground through the atmosphere, from that distance, you would need generating capacity and an aperture that no orbiting object has ever carried. None of this proves nothing is happening to anyone. It does show that the mechanism named on the table cannot be the explanation. There is a standing counter-argument, and it deserves a straight answer. The Mind Justice Report to UC Davis, held in the knowledge base, objects that dismissals ignore the large classified research known to exist in this area. That objection is partly fair. Some capability genuinely is classified, and the same report cites the historian Jeffrey Richelson on classified satellite systems. But notice precisely what that supports. Supports we do not know. Classification supports we do not know. It never supports, therefore it exists. Those are different sentences, and the second is this genre's characteristic failure. Absence of published capability is not evidence of a hidden one. A locked filing cabinet does not tell you what is inside it. The honest position is that the secret parts of the record are secret, and that we cannot build a case in any room that matters on what we cannot see. Carry forward 3, the most durable of them. Grade the row, not the page. The habit that protects both researcher and target is refusing to render one verdict on a whole document. Weigh each claim against its own evidence. Let a confirmed fact and an unproven assertion sit honestly beside each other, neither one borrowing the other's credibility. That is slower than a verdict. It is also the only reading that survives contact with someone determined to discredit you. 8 questions, then, and they take about a minute each. Who says so, and in what document? Which register does the claim belong to? Demonstrated. filed, or claimed. Whose words are these, the inventors or the caption writers? Is the mechanism physically possible at the stated distance and power? And finally, the question people skip: where exactly does the evidence stop? Ask these of the rows you want to be true as well. That discipline, applied across 1,000 pages of contested testimony, is the foundation this whole series is built on. It is what TI One Voice does with a crowded table. Separate the documented from the merely asserted, row by row, so that real evidence never borrows credibility from the claim beside it. The archive is at one.witisk.org. What remains is the question of what such a record is finally worth. Before we close, one feature of the table deserves a final look, and it is not in any row. It is the column the compilers added on the right, headed Potential Good Use. Look at the structure rather than the content for a moment, because the structure is telling. Every row that names an alleged crime is paired immediately with a benevolent purpose. Why build a table that way at all? Here is what that column actually says. 4 of the 5 rows carry the identical justification, word for word: to monitor and stop terrorists and other criminals. Echelon gets it. The audiovisual satellites get it. The interactive transector gets it. The neurophones get it. Only the consciousness-altering row breaks the pattern, offered instead as a way to help emotionally distressed persons. A softer line, but still one that frames the technology as benevolent. That repetition is worth noticing on its own. A genuine case-by-case weighing of costs against benefits would produce different justifications for technologies with different risk profiles. Instead, the same sentence is stamped across 4 rows. When one phrase answers 4 completely different questions, it is not answering any of them. The column exists to perform reasonableness, rather than to actually reason. That is a judgment about the writing, not about the world. Consider how different those questions really are. Echelon, a global interception network, can at least be argued to serve a counterterrorism function. That is a debate about proportionality and oversight. A device that allegedly beams voices into a skull from orbit raises a different question entirely, about necessity and about what threat could possibly justify it. And altering an unwilling person's consciousness raises a third question, about consent and the boundary between security and torture. None of this makes the criminal use claims false. A document can deploy an identical justification across every row and still describe its technologies accurately. But the boilerplate does tell us what kind of document we are holding. It is an advocacy artifact, assembled to make a case, not a neutral technical survey that weighs each technology separately. Knowing which kind of document you have changes how you read every line of it. So here is the practical rule that falls out of it. The table's framing deserves less evidentiary weight than its checkable citations, because the framing was assembled to perform a function while the citations can be pulled and read. Patent number survives that test. A rhetorical column does not. Our knowledge base entry on satellite surveillance puts the underlying tension plainly, and it is a tension, not a verdict. Let us pull the whole episode together now. 2 hours on a single page of 5 rows, and the finding is that one page holds 3 completely different kinds of claim. 1 row is documented. 1 row is asserted and physically implausible as literally written. And 3 rows are real, checkable documents wearing a label their own authors never wrote. A single grade for the page would have hidden all 3. Row 1, Echelon, remains the load-bearing fact of the page. In September 2001, the European Parliament adopted the report of its temporary committee, after roughly a year of sworn testimony, and concluded that a global interception system of this kind did exist. The ground stations are real and photographable from public roads. What is documented is the system. What is asserted, still, is its use against any named individual. Row 2 ran into arithmetic. To resolve 10 centimeters on the ground from 36,000 kilometers up in visible light, you would need a mirror about 220 meters across. The largest ever launched on Hubble is 2.4 meters. That is not a refinement problem. And no optical sensor at any altitude sees through a roof. Imaging is not identifying, and identifying is not tracking a person. Keep the second distinction just as sharp. Observing is not acting. A sensor collects energy that is already arriving. A weapon has to deliver energy across the same distance, and the two problems are not symmetric. Power falls off with the square of range, beams spread with distance, and the atmosphere absorbs much of what is left. That is why the catalog of orbital sensors is long, and the catalog of orbital weapons aimed at people is empty. Everything checkable in this episode reduces to 6 dates. 1962, Alan Fry publishes the microwave auditory effect in a peer-reviewed physiology journal. 1968 and 1972, Patrick Flanagan neurophone patents. 1990, Larry Rowan's interactive transector. 1992, the first of James Gall's consciousness patents. And 2001, the European Parliament's report. 6 dates, 6 documents, every one of them available to you tonight, free in an afternoon. Say the third finding as precisely as it deserves. 3 genuine United States patents, 3 real inventors 26 years apart, and the numbers in the table are accurate. Not fabricated. But not one of those 5 filings contains the word satellite. A contact hearing aid, a weapons targeting system that never mentions orbit, and an acoustic entrainment method sold as a relaxation aid. The orbital claim was added on top. That gap is the compiler's work. And yet the sky genuinely does hold a great deal. Real reconnaissance and communications satellites. Real signals intelligence partnerships intercepting an enormous volume of global traffic. Real ground stations at Menwith Hill, Pine Gap, and Sugar Grove, whose antennas you can photograph from a public road. Real scholarship documenting the gap between what those agencies can do and what any democratic body effectively oversees. None of that needs the table's 4 unproven rows. Now the honest column, because a closing that only lists findings is a sales pitch. What we still do not know. Some orbital capability genuinely is classified, and that supports the sentence we do not know, never the sentence therefore it exists. Who compiled this table and when we could not establish. Where the phrase sat-based first attached itself to these patents we could not trace. And physics cannot explain anybody's experience. Our knowledge base entry on satellite surveillance ends its own survey with a sentence worth borrowing, because it refuses the easy landing in either direction. Constellations are proliferating. Revisit times are falling from hours toward minutes. And the questions that matter are not whether the technology is frightening, but who oversees it, under what law, and with what remedy when it is misused. Those questions stay open and they are answerable. A word to anyone watching who is frightened by that table. Nothing here rules on what is happening to you. Setting aside an unproven mechanism does not set aside your experience, and it is protective rather than diminishing. Lean on the satellite and a skeptic asks you to prove the satellite. Lean on a parliament's report, a published effect, a patent number, and the burden moves back where it belongs. Everything in this episode is traceable, and that is the whole method. 5 patent numbers from the United States Patent and Trademark Office. The European Parliament's report, A50264, adopted the 5th of September 2001. Phrase 1962 paper in the Journal of Applied Physiology. Bamford, Aldrich, Richelson, and Lyon on the agencies themselves. And the knowledge base entries behind the rest. Nothing on this page asks you to take our word for it. If this way of working is useful, it does not have to be a solitary one. TI1 Voice lives at 1.witisk.org, a searchable knowledge base with the contested parts labeled contested, a declaration you can sign, and a place to log what happens to you in a form that holds up later. TITV runs around the clock at meet.witisk.org. Under Public, TITV. Next time we leave orbit and come back down to the antenna on your street. Part 17 is the weaponization of 5G, 6G and massive MIMO arrays. Massive MIMO is real engineering, hundreds of antenna elements steering a focused beam at one handset. The claim is that this is the ground-based successor to the satellite table we just read. What is genuine, and what is the next and proven leap? We will read it the same way. Thank you for giving 2 hours to a single page of 5 rows. You leave with 5 patent numbers you can pull, 1 parliamentary report you can download, 1 physical limit you can check with a pocket calculator, and 1 honest sentence about where the record stops. Grade the row, not the page. Carry that into rooms where it will be tested, and we will see you next time in Part 17.